Teaching mathematics requires absolute linguistic precision. If a teacher's language is ambiguous, the student's operational logic will be flawed. At the most basic level, a fraction simply represents a part of a whole. Technical terms in the classroom function as specific operational instructions. When a student attempts to divide or subtract fractions without first mastering the vocabulary that defines their structural properties, cognitive overload occurs. To build a rigorous instructional baseline, we are reviewing the 14 essential English vocabulary terms utilized in Year 8 Australian mathematics classrooms. We will sequence this review progressively, moving from the isolated anatomy of a fraction to the integer tools required for advanced operations and ordering. Internalizing this exact lexicon equips you with a precise communicative tool that eliminates ambiguity and reduces cognitive friction for your students. We begin with the structural coordinates of a single fraction. Isolating the fraction 3/4, the top number, 3, is the numerator. It dictates the parts currently being manipulated. Shifting focus, the bottom number, 4, is the denominator. It dictates the total equal parts required to construct one complete whole. These two isolated numbers function together as exact coordinates, defining precisely what portion of the whole is active in an equation. Once the anatomy is clear, we categorize how fractions express differing states of magnitude. Here we see the fraction 3/5 displayed on a visual scale. Because the numerator is physically smaller than the denominator, it is defined as a proper fraction. A proper fraction always represents a total value of less than one complete whole. Conversely, when we examine the fraction 7/4, the top value outweighs the bottom. This defines an improper fraction. An improper fraction represents a numerical value equal to or strictly greater than one complete whole. Watch as 7/4 is mechanically converted into 1 3/4. By isolating the whole number component from the fractional remainder, we create a mixed numeral. Depending on the format a specific operation requires, pre-service teachers must train students to fluently translate between improper fractions and mixed numerals. We now introduce the abstraction that a single mathematical magnitude can hold infinite fractional identities. This visual equalization proves that the fractions 1/2, 2/4, and 3/6 hold the exact same value. We formally define these distinct representations as equivalent fractions. While the integers change, the underlying ratio between parts and the whole remains perfectly constant. Grasping equivalency is the non-negotiable gateway concept before any student can attempt to add or subtract unlike fractions. To manipulate that equivalency, we rely on specific integer mechanics. The first tool is factors. Factors are whole numbers that divide exactly into a target number without leaving a remainder. Taking 12 as our target, this web maps its complete set of exact factors, 1, 2, 3, 4, 6, and 12. The second tool is multiples. Multiples are the sequence produced by continuously multiplying a base number by other integers. For 5, the list expands to 5, 10, 15, 20, and 25. Factors function as the mechanism for scaling fractions down, while multiples function as the mechanism for scaling them up. We combine these integer tools to compare and manipulate multiple numbers simultaneously. Cross-referencing the factor sets for 12 and 18, we locate their shared intersection at the number 6. This defines their highest common factor. Pedagogically, the highest common factor is the fastest tool for simplifying a fraction to its lowest terms. Next, we compare the evolving multiples for 4 and 6. Highlighting their very first point of numerical intersection gives us the lowest common multiple. Identifying the highest common factor and lowest common multiple provides the essential mechanics required to standardize differing fractions. This standardization enables the execution of fractional addition. In the operational equation 1/3 plus 1/4, the lowest common multiple of 3 and 4, which is 12, drops into the denominator position. This creates the lowest common denominator. The lowest common denominator is functionally identical to the lowest common multiple of the original mismatched denominators. Transitioning from the mechanics of addition to the mechanics of division, we introduce the reciprocal. Taking the fraction 3/4, we physically invert it vertically. The resulting structure, 4/3, is its reciprocal. Teaching the reciprocal gives students an operational switch, strictly used to convert complex fraction division into straightforward multiplication. The final conceptual stage requires understanding the relative value of fractions within a larger comparative system. As these values arrange progressively from smallest to largest, they are in ascending order. Executing the exact reverse places them in descending order. A student's ability to sequence fractions proves they have successfully synthesized equivalency, numerators, and denominators into a cohesive mental framework. We have traced the pedagogical journey from isolated fractional anatomy straight through to comparative sequencing. This typographic grid maps the interconnected architecture of the 14 core terms we covered. Successful fractional operations are strict, logical systems built entirely upon these specific definitions. Internalizing and enforcing this exact vocabulary ensures clarity, consistency, and confidence in your daily mathematics instruction. Rigorous mathematical language gives you the mechanism to prevent systemic confusion, allowing you to construct an unbreakable baseline for your Year 8 students.